So by clicking the crank 1 constraint, it opens this dialog. And so now what you need to do is to put the Revolut motor on it. Yeah, put the Revolut motor, close, and then we'll see. Now the situation is different because now you can see the crank is working in only in one, the crankshaft only working in one direction, and that is the situation here. Mm. So now let's go back to our tutorial in here. So you see there is they changed the Revolut joint to a Revolut motor, is what we have done. Now it doesn't behave yet but like the piston should. So to complete this model, the piston head motion needs to be confined to a vertical slot. So click on the workspace to deselect all components, and the necessary press I for isometric view. And on the Create Constraint tool, click the down arrow and select the Revolut joint on slot. So this would be a Revolut joint on the that actually moves on slot. In this case, if you put it on top of the piston, it's as if you have created a path that the piston can only go up and down, like a piston should work. So in this case, we go over here to this, the tool in here, right here. That's the dialog that you see on the right. And then we put Revolut join on a slot. Okay, so there you go. This is Revolut join on a slot, and then click on the top face of the piston and press enter right here. Click over here and press enter. And that did this constraint number 58, which is the constraint so that the piston would actually move in a vertical position. So in here we have, this is the, there you go. What a difference, huh? So now we have the piston working in the way it should. The illustration here that we're doing by doing this demo is that you could bring in parts to this program, and then you, by using these constraints that you see here, you can actually have those parts become alive as a system. So in this is the situation is that you have the crank in there in this, and you have also the slot in there, and therefore the constraints make the system behave the way you want it. I think what is showing you is that you have the crank motor driving the crankshaft and the piston following on a vertical motion as it should. So let's go over here and continue with what we're doing. Then say reset, and so we're gonna go to our further tutorial. It says now how do we measure the angular velocity of the motor. So in this case, you are gonna click on the constraint on the components list, which is the one on the top. And then from the insert menu, select meter and then angular velocity. So we are going to go over here and see if we pick up the crank one constraint. Yeah, right here. Let's stop this one right now. And then it says click on the insert menu and then insert meter. And then we are going to go to the angular velocity, which is over here. See what it did is the program now divided this into two things. And we need to look at the windows like that. It has a tile for the system, and then it has one for the measure of the angular velocity. Because what we're doing is we're doing now dynamic things in here. So you will see in here we're gonna run, and then there you have the measure of the angular velocity of this, which is a constant, right? That's what you should expect to see. So everything has to be, you have to see it according to the reality. So we're gonna go here and say reset. And now another exercise in here is that you're going to see the, say for example, changing units. You can change various settings, and sim-wise for the number to digits, colors, change units from the word menu, select display. In the settings dialog, click on the units and change the unit to SI system, unit system SI and degrees, and change the rotation to RPM. Let's just do that. So what it's saying is you go here to the word menu, and then select settings, display settings. And here in this dialog, you will see click on the units over here, units right there. And then you could actually change the system to the SI system, unit system. Here's SI system in degrees, and then the rotational velocity, you can change it to RPMs right there. The velocity you could do in miles per hour if you want, but the exercise here is based on what we have here. So we close this. Now we want to change the angular velocity of the motor. To change the default motor and angular velocity of the motor to a torque motor, right click on the crank one constraint in the component list and then select properties. So we crank one constraint, and then we need to select properties. Well, this is the properties over here. In the properties window, do the navigate. No, wait a second. Here we go. Properties. Here we go. Select the torque radio button, it says here. And enter the value of 50. This is a value for the torque input in here. You say apply. Yeah. So we click on close. Mhm. Yeah. So let's just go and observe what it does now. See, this is what they is asking us to do. It says it is chopping, choppy motion in there. And so let's do a reset, like this. Okay. So something is we need to fine tune here. Now this is the 2.8. We need to display the display rate. The piston rotates too quickly and looks choppy. To smooth the simulation, select from the Word menu, select Simulation Settings, click on Integration, then change the animation frame rate to 2000. So this is going to, changes too quickly. So we're going to smooth the simulation. Word menu, simulation settings in here, and then it says integration on the left hand side in here. Where is integration? Right there. And then it says the rate, the animation frame rate. Here the number of frames per second. We need to change it. This is the one. Instead of 50, we're gonna do 2000. Now apply and close, and let's see what happens now. Now the situation is much better. See? So it is actually behaving like the motor should behave. So in here we do a reset of this. You'll see it again. Starts slowly and then accelerates because you have a torque that is as the input in here. The input is not a constant angular velocity as before, but the moment you put the torque, it will develop whatever velocity it results from. So that's what we're doing here. Now then we are to 2.9 in here for the finite element analysis and factor of safety. So to perform the finite element analysis, you on the connecting rod, for example, right click on it and select including FEA and make sure the simulation is at frame 0 by clicking the reset. Well, okay. So you double click over here. Wow. And then you say including FEA. I didn't see that it allowed me to. See over here. There we go. Including FEA. There you go. So if you include an FEA, the program still does what it needs to do there before. But if you go to animate motion with FEA, then the situation is going to be different. See, because okay. That was not very nice.